Hello everyone, welcome to my channel. Today we are going to discussing a problem which just came in 2 times in CSIR exam. That is CSIR June 2015 and recently CSIR NTA December 2019. Okay, so let's solve this question and try to understand the whole process of this reaction. Okay, so the question is the major product formed in the following reaction is there is a substrate given like this, and you have given this kind of reagent, that is tosyl hydrogen in acetic acid, and then you have given a sodium cyanoborohydride, and there is a temperature that is 70 degrees Celsius. Okay, previously I tell you that previously I said that this every reagent has a role in the reaction, in the specific reaction. Okay, so here also happening the same thing. Okay, now the question is one more thing is that now the question is directly taken from Caruthers. Okay, you can check over there. I will put the link of this book on the description section, and Caruthers in page number 449. I mention it here. Caruthers, page number 449. You can check over there. Okay, I will put this PDF link and in the description section. Okay, now there is a reagent. Okay, there is a reagent that is para-tosyl hydrogen. Okay, let's do and solve this question here. Now I have given para-tosyl hydrogen. Okay, now what it can do, there is a nitrogen lone pair of electron, it can attack over this carbonyl atom, and the negative charge goes back to the oxygen atom, and there is a formation of this thing, and I'm writing not full writing, I'm writing the short way, that is minus H plus plus H plus, and acetyl, this is OH, there is NH and NHTS, and this part also. Now see, here is a lone pair of electron, it push back here and this goes here. Okay, so now there is a problem, there is a substrate that you have, sorry, this is a methyl CH3, there is acetyl group, and there is a double bond in NH, it is positive, a positive, and NH and TS. Okay, so this positive will neutralize by removing this hydrogen, so I am miss it, and here. Okay, so this is the overall product after a reaction of para-tosyl hydrogen. Now you have given this reagent, that is sodium cyanoborohydride. Now this is a very important reagent in the reagent chemistry, and this is also a chemoselective reagent. Okay, so I am writing this is here sodium cyanoborohydride. Okay, so this is very much chemoselective. Why I am saying it's chemoselective? That now see, you all know the reagent, that is sodium borohydride. Here is the extension of one hydrogen, or one hydride is replaced by a cyanide group, that is very much electron withdrawing in nature. So that is why this reagent is very much chemoselective, and its reactivity is very much lower comparative to sodium borohydride. So you have to know one very important concept, that is if a reagent has a lower reactivity, then its selectivity is much higher. It is very important concept that you have to know and you have to consider it. And I am writing this thing here, that is, if any reagent has a very much reactive, then its selectivity lower, or if the reagent has a lower or lesser you can say easily lower reactivity, then the selectivity is much higher. Here is your this condition, that is, you have given sodium cyanoborohydride, and that is very much less reactive, compared to sodium cyanoborohydride. So if it is less reactive, then its selectivity is much higher. So okay, you have to know if you given the structure, if you have given the reagent like this, then sodium triacetyloxyborohydride, it is also a chemoselective reagent like sodium cyanoborohydride. Okay, now if in general condition aldehyde and ketones are unaffected by this reagent, but if the pH is increasing, that is pH is 3 or 4 is higher pH, so there is a protonation of the carbonyl group, then the reduction will proceed. In case of pH higher, that is pH 3 or 4, if pH 3 or 4, in this pH, this sodium cyanoborohydride will reduce aldehyde or ketone. Okay, now you have given this in this substrate or in this compound, after the reaction of tosyl hydrazine, you get that this type of structure, this type of compound. Now this type of bond is called imine bond. Okay, imine. Now sodium cyanoborohydride usually reduce the imine. Okay, in this condition, so there is no pH or anything else, so it can easily reduce this imine. Okay, so I am writing here, if the imine reduced, then what will be your product? This is methyl. Now see, if imine is reduced, then your product is like this, just because of what it can do. It can do only a hydride transfer. By it can reduce any of this group or any group, whatever it is, it will reduce via the hydride transfer. So this hydride is here, and there is a negative charge, and after its negative charge capture a proton, and there is a proton. So there is a 2 proton here, and NH here, and NHTS. Okay, this is your product after the sodium cyanoborohydride reduction. Now see, there is a tosyl group, so this tosyl group is easily removed from the system. But by how? This negative charge push back here, and this goes from the system in the form of para-toluene sulfinic acid. Okay, I am writing this easily here, TSH. This is called para-toluene sulfinic acid. Okay, now see, so there is a leaf of T minus TSH, and after that you get this one, and double bond in, and there is a hydrogen like this, and this hydrogen is removed from the system to neutralize this nitrogen atom, and here this. Now you have given one interesting interesting thing is happening here, that is you have given a 70-degree temperature. Now this temperature has a major role. So what it can do, there is a 1,5 sigmatropic rearrangement, 1,5 sigmatropic hydride transfer. Just now see how this 1,5 hydrogen transfer will occur. Now I will numbering here 1, 2, 3, 4 and 5. Now this hydrogen will migrate here, this will go here, and this will leave from the system as a nitrogen gas. Now this nitrogen leave from the system, and after that you get this type of structure. You get this, there is a double bond, and after that you have, after this hydride transfer, make hydride transfer, there is a hydride and silyl group, and there is a hydride like this. Okay, so this is 1,5 sigmatropic hydride shift. Okay, so this is the overall mechanism and overall concept of all this question. Now let's have a look of the option. So this will not your option, this will not your option. Here is your option, it is this one, option C is the correct option. So this is not your option. Okay, now you can check the Karuthar's book. I will put the link on description of this book, and you can download over there, and your page number 449 you can get easily. Now how much important question it was, that is the 2 times CSIR exam they come this question. Okay, so I think I covered all those concepts related to this topic, and I hope this video will be very much helpful for you or useful for you. And please subscribe to my channel and please press the bell icon for new updates, and thank you so much for watching.